So I showed you how to get all the information you need, all the bits that you need to bring together in order to sketch the graphs accurately at this level. What I'm going to do here is I'm going to give you one example. I want you to have a crack at the example, then come back and compare what you've got with the working I'm then going to show you. So here you go. I want you to sketch the graph of the following function showing as much detail as possible, and I'm giving you the function 3x plus 6 over x minus 1. So pause the video, have a crack at that and come back. So we've got the 5 questions we need to ask ourselves. So the first one that we're going to look at is the intercepts. So if we set x equal to 0, we get the intercept of what would be the y-axis, and in this case we end up getting negative 6. If we set y equal to 0, we get the intercept of the x-axis, and in this case we would know that x is equal to negative 2. 3x plus 6 equals 0, x has to be equal to negative 2. So the next thing we're then going to look for on the curve is we're going to look for stationary points. And in that case, what we have to do is look at the derivative. So f dashed of x, which in this case, when we calculate it, f dashed of x is equal to negative 9 over x minus 1 all squared. Now, one thing you should notice is that x minus 1 all squared is always positive. Negative over a positive is always going to give you negative. So that means that the curve is always going to be decreasing, except when we have stationary points. So if the curve is always decreasing, it's always going to have a negative gradient. Now I've said except when we have stationary points, so when f dashed of x equals 0, but in this case, for that to be true, negative 9 would have to equal 0. That can't happen, so there are no stationary points on the curve. Next thing we then have to look at is any other points of interest in the concavity of the curve. And in order to do that, what we have to do is look at the second derivative. Now the second derivative of this function, when you take it, is you get 18 bracket x minus 1 over x minus 1 to the power of 4. What we want to do is look at that equal to 0, and what that'll do is then it'll tell us about any non-vertical points of inflection. So if we set that equal to 0, the top line has to be equal to 0, so x is equal to 1. So that's where it would occur, but same logic as what I showed you previously. If x is 1, the bottom is 0, so I'm dividing by 0. So what that means is there's no vertical points of inflection. So I can rule that out straight away from my curve. What I'm then looking for is my asymptotes. So in order to look at my asymptotes, I have to have it written in the correct format. So what I have to do, top power is exactly the same as the bottom power, so I have to do algebraic long division one time to get it in the format that we need. So if I do my algebraic division once, I do x minus 1 into 3x plus 6, just as we practiced. What I end up getting is 3 there. I then get 3x minus 3, subtract them from each other, and I get 9. So I can then write my f of x. It's going to be equal to 3 plus 9 over x minus 1. And from that, what I can now do is get my vertical and my non-vertical or oblique asymptotes. So for my vertical asymptotes, what I have to do is look at the bottom and state when x minus 1 equals 0. And in this case, it would be x equals 1. So I know I've got a vertical asymptote occurring when x is 1. My non-vertical ones, that's what happens in front. So in this case, I focus on the 3, so I know my non-vertical asymptotes occur when f of x is equal to 3. So I've got a horizontal asymptote occurring at that point there. What I now need to do is look at the behaviour of the curve as it approaches those asymptotes. So again, let's do a very rough sketch before we go and do the good one. So I know I've got a vertical asymptote at x equals 1. And I know I've got a horizontal asymptote occurring when f of x is equal to 3. So what I have to do is ask myself what happens as x tends towards positive and negative infinity. So what's happening as x goes towards that direction and that direction. Then I look at what happens as x gets closer and closer to 1 from both sides. So what I say is, right, so if x tends towards infinity, let's look at that one first. As x tends towards infinity, the bottom here is always going to be getting bigger, which means that my fraction is going to be getting smaller. So I'm going to have 3 plus a tiny number. So it's always going to be above 3. So what that means is as x tends towards infinity, my f of x tends towards 3, but it's 3 from above. If I then look, the same logic, x tends towards the negative infinity. As I go off in this direction, the bottom's always going to be a negative number, so it's going to be 3 take away something. But again, as I get closer and closer to infinity, the bottom gets bigger and bigger and bigger, so my fraction continually gets smaller. So ultimately it's 3 take away something, regardless of how small that is. So what I then know is that f of x tends towards 3 from below. So as I go off in this direction, I'm going to be below it, and as I go off in this direction, I'm going to be above it. What I now want to do is look at the behaviour as x tends towards the 1 from above, and x tends towards 1 from below. So if I approach my x equal to 1 from this direction here, the size is always going to be bigger than 1. So my bottom's always going to be positive. So I'm going to have 3 plus a positive number. But that positive number here is going to get bigger and bigger as the denominator gets smaller and smaller. So I'm going to start increasing the size of the number as I get closer and closer, and until I get infinitely close to it. What I then know is that as x tends towards 1 from above it, f of x is going to tend towards infinity. So it's going to tend up towards this direction. If I then look at it coming from below, what I know then is that whatever value of x I choose, it's either going to have a size that's less than 1 or it's going to be a negative number. So in that logic, this is always going to be negative. As I get closer to 1 from below, it's going to be negative, so 3 take away something, but the size of the fraction is then going to get infinitely bigger. So I'm going to tend towards negative infinity as this gets bigger and bigger and I get closer to 1. So it's going to tend towards there. So I've got all the information I now need in order to be able to sketch the graph. So let's go and do that now. So first thing I have to do when sketching it, I always set up my axis first. So there's my f of x axis there. I then draw my horizontal axis, my x. Then I mark on my asymptotes. So I've got a horizontal asymptote going along here, and I know that that's at f of x equal to 3. I then have a vertical asymptote going up and down there, which I know occurs when x is equal to 1. So that's the first bit of information I've got. What I also know is the behaviour of the function as x tends towards negative infinity and positive infinity, and then as it gets closer and closer to 1 from each side. So I know as it gets closer and closer to 1 there, it's going to be down at negative infinity, it's going to be up at positive infinity here, and I know in this direction when x tends towards positive infinity, it's going to get closer and closer to the asymptote but never quite touch it. Using that information, I can sketch that part of the curve there. I also know as x tends towards negative infinity, I'm going to get closer and closer and closer, but never quite touch there. So I've got that information there. But what you also have to remember is you have to take into account your y and your x-axis intercept, and I know they're both negative. So in this case, the curve is going to look something like that. And I can mark on my x and my y-axis intercept. I know it cuts f of x at negative 6, and it cuts the x-axis at negative 2. So that's me sketched it, and I've marked on as much information as I possibly have. The curve is always decreasing in all directions. I know how it behaves as it approaches the asymptotes from both sides, and as x tends towards positive and negative infinity. This is all the information you need to make sure you mark on this curve and these types of curve when you sketch them. You have to show everything you've calculated and everything you know to accurately display the behaviour of the curve itself.